Hello, everyone. Welcome to another Cosmic Conversations. John, you can come out now.
Hi, everyone.
This is Dr. John Feldmeier, YSU Astronomy Professor, here to talk with me today and with you about exoplanets, planets that orbit other stars, not in our solar system, but way out there. If for those of you who are watching, I see a few of y'all on, say hi in the comments. Let me know where you're coming from. And if you have any questions for us as we're going, please let us know. If you have any, even just comments or things you wonder or whatever, we're here to chat with you about all things exoplanets. Thank you, Dr. Feldmeier, for coming on today. I'm so excited.
Yep. Exoplanets are exciting. There's really you don't have to work very hard to sell exoplanets. I mean, planets around other stars are pretty amazing.
Yeah, other worlds, come on. Who does not think that that's interesting? So, and it's a relatively new area of astronomy, which is one of the things that I really enjoy about astronomy is that it's ancient in some ways, and it's cutting edge modern science at the same time. And so exoplanets, in my mind at least, is sort of this area of astronomy that's emerging and is changing every day. In fact, you mentioned before we went live that your notes you just updated, there was 3 more confirmed planets from like yesterday, right?
Right. So yeah, there's a website that actually keeps track of all the exoplanet discoveries, and I was looking at that web page for a different reason last week, and just before the thing, I better check the numbers. So as of today, there are 4,723 planets around other stars.
Nice.
And as Tiffany said, they've all been discovered since like 1994, which is, not that long in astronomy space, right? Most of us have been around that long to see it. Not everybody, but most of us.
Do you want to talk about the first planet that was ever discovered that was not in our solar system? What was that like?
Sure. It was pretty cool because I was a graduate student at the time, and kind of by chance, one of the other graduate students went to the science meeting where like the very first announcement was, and he basically came back and said, guys, remember, this is kind of like early internet, right? Like carrier pigeon, but he was like, guys, I just saw this talk about this planet around 51 Pegasi, and we were all kind of jaded. We're like, no way, that can't be real, because there was a long history before that of people thinking they saw a planet around something, and it turned out not to be true. So we all kind of knew to be skeptical, but he's like, no, they have really good data, except its period is 4 days. And we all went, what? Because just to put in perspective, Mercury going around the sun is a period of about 55 days, and the period of this planet was about 4 days. And we were like, that means the planet was very, very close to its star.
So its year, this planet's year is 4 days, 4 Earth days,
right?
Basically.
So
yeah.
So I think my granddaughter would be 90 years old. Right? in this planet. But so that was weird right there. So those types of planets and more were discovered are called hot Jupiters, because they turn out to be about the size of Jupiter. I think that one was about half the mass of Jupiter, but they're very close to the stars. And so even the first exoplanet that was discovered was a little weird. And we're like, that's not what we expected, but that's the exciting part. You learn something new because it was something new that we did not expect.
Yeah, and I mean, exoplanets, even now that we know that they're confirmed, they still have this almost sci-fi quality to them. I mean, people have written stories about exoplanets for ages, well before we discovered these. So it's an exciting time to be able to kind of confirm these ideas that we really aren't alone out there. I mean, we have not discovered life yet, but this is a big step towards understanding the universe out there and what is out there.
Yeah, absolutely. I mean, there are clearly weird. There are weird types of planet systems that no sci-fi writer would have predicted. I mean, a really good one is the one right behind Tiffany's head that we can talk about later. It's called TRAPPIST-1, and I don't know any sci-fi story that predicted something like that. And people keep finding new ones all the time, and sometimes it's like, oh, that's one of the other ones, and it's like, whoa, what is that one? That's weird.
So it's only been, I don't know, less than 30 years, 25 years maybe, since this exoplanets were confirmed and this new area of astronomy has started. And you and I both have done some research in exoplanets, even though neither of us are exoplanet scientists, like that's not our thing, but we've both done some research in that area. And you have even found a planet, right?
Oh, yes. Yeah, that's right.
You gotta share this story.
So out of the 4,723, I helped discover one, but
Nice.
I'm happy to tell the story. So one of the easiest ways, or actually the most successful ways to make extrasolar planets, I can show you with my hand and my finger. So you pretend that you're a telescope, and this is a star. And if a planet is perfectly lined up like so, it will cross in front of the star. And so that's called a transit. It happens in our solar system. You see, every so often we see Venus do this. And so, for anybody watching, like Google Venus transit, it's a very cool picture. What that means is that the star just gets a little bit fainter as the planet crosses in front of it. And so I was part of a team of, I think, 21 astronomers that used a telescope that was originally in Cleveland and then moved to Arizona. And we observed the same spot in the sky for 40 nights. And we found, a number of objects that looked like planets, but it turned out that in the end, we had 3 good planet candidates. And then one of them, which is called Box-1, or Winston is its nickname, is the planet that was confirmed by another satellite. So that was fun because it was a very crazy kind of observing, because we observed the same spot all night and we observed night after night, and it was kind of a giant relay race. I didn't observe for 40 nights, but somebody was always at the telescope, and most of the time in astronomy, you usually are moving the telescope around as you observe, but basically you would set up on the one spot and then you would just stay there all night until the target had set. So it was kind of, in some ways, the most boring observing I've ever done. But it was also the most exciting. It was pretty exciting to see as the data came in that we were getting closer and closer to finding a planet. So that was pretty exciting too.
Wow, that's one more planet than I've discovered. So, and I really love that story because it was a big team, right? And this is something that we don't talk about a lot. Even in your story, which is sort of the classic version of observing, you used a telescope on the ground and you looked up every night. It's still, so one person wasn't driving themselves insane by staying up all night every night for 40 nights. You had a whole team of people taking turns to do that. Wow, it's a lot of work, but that's exciting. Why is it nicknamed Winston?
Oh, so there was a joke that we almost everybody who does planets, like there's a nickname or something, and I told everybody years ago that I didn't care about anything but the first planet, because I only thought we might find one. So I was like, we're gonna name it Winston after my old dog, and they went ha ha. I'm like, no, we're gonna name it Winston. So just so everybody knows, it's not its official name. It's Box-1, Kepler 71. But we code named it Winston, and a lot of astronomy groups do this. They'll name targets so that way you can talk about them in emails and things without giving them away, or everybody knows what you mean when you talk about the Winston object or something like that. So that's why it's named after my dog.
Kind of reminds me of that Tom Hanks movie Castaway. His little friend that he had on the island with him.
Yeah, Wilson, I think, right? Yeah.
Kind of apropos. That's awesome. So we both did work with Kepler, which was a space telescope, a telescope that was orbiting Earth, and it was staring at one part in the sky for years. It was staring at a square, a field of view in the Cygnus constellation, which is up tonight and in the summertime. So it's a good time to go see that. And it just stared at that spot for years, studying that collection of stars. And as you mentioned, the transit method, that's a way to discover exoplanets, is you wait, and the solar system can't be, face on, it's got to be right edge on, just kind of like you see in this picture. It's got to be oriented just right with how we're observing it. But assuming that those solar systems are oriented in a way that the planet going in front of the sun actually passes between us and that star, and we can see that periodically, then we can start to confirm these planets. And what happens is as the planet goes, and if this is a star, it's shining, and then a planet goes in front of it, it's going to shine just a little less bright. So it'll appear like it dims just a little bit, very, very sensitive, but you can collect that data. Okay, the star went dim, and then 4 days later, the star went dim. And then if it goes dim again exactly 4 years later, well, then suddenly you have a period, and so something is going around that star. And that's how the planets with the Kepler space telescope was. How many confirmed planets did Kepler have? It was thousands, right?
So it was thousands. I mean, I think you could say of the planets that I talked about easily half of them were from Kepler, because Kepler was just ingeniously designed. And one of the guys that was on our little project is a big wig in the Kepler project as well. So there was sort of a cross, but don't okay, I want to be very clear. It's Kepler, right? Like it was like the whale and the minnow, but it's the same idea. And one of the amazing things about Kepler is they could look for very tiny dips in the light, like 20 parts per million, which
Wow.
is very precise. And Tiffany's right. One of the things, is it took time, because of course you see the transit signal, but you want to be sure it's a real thing. So you really want to see it twice, because now you have a period, and you really want to see it at least 3 times.
Mm-hmm.
And then the next step is, if you start noticing, are there other eclipses, which is like what the TRAPPIST system was, where there are like 6 planets. So there's like not just one set of transit dips, there was actually 6 sets of transit dips.
Yeah, so this is I think 7 actually.
Yes, my bad. Yes, you're absolutely right. There are 7.
So this is an entire solar system that was discovered. I believe this was discovered with Kepler, right?
So TRAPPIST is one of those ground-based telescopes, but then Kepler looked at it.
That's right.
And Kepler got the really good, perfect, awesome data. I mean, Kepler is so much better than the ground-based transit telescopes. I mean, the transit telescopes on the ground are good to look at different spots in the sky, but Kepler was at the time like the most precise thing ever. So they went and looked at it later.
Yeah. So Kepler being in space, not having to look through all the clouds and our atmosphere and things, has much more sensitive instruments that can see more clearly. And this TRAPPIST here is around these 7 planets around a very dim red star. It's very small compared to our star, our sun. If you look in the picture below, that little green disk there, that would be TRAPPIST. It would fit inside the orbit of Mercury. So all these planets are very close to their sun, to their star, but their star is small and cooler than our sun. So it's okay. They're not fried.
Right.
Not some of them. So we have a question from James. Since you need to repeatedly observe the dimming of a star, does this eliminate long years for more distant planets?
Yes. So this is a thing you can see in the graphs, and we all know this as scientists, is that we call this, the buzzword is a selection effect. Is so very long period planets have not really been discovered with Kepler, because even though it did observe for 5 years, that means the longest period you could sort of see would be like 2.5 years, right? And that's
Which
just
is
a
about
limitation.
Mars, right?
Yeah.
Something like that.
There are other techniques that are a little harder that let you see longer period planets, but obviously, that's the unknown still, right? So I think that Kepler mostly, when they talk about their planets, they're usually talking about periods of 1,000 days or less, and that's, I mean, it gets harder to observe planets as they get to longer periods. But it's not just a little step where we don't find any planets. It just gets harder and harder until you have no chance. So that's a giant but that's still an amazing data set. But if we could say detect Jupiter from a transit, we can't yet do that. Trust me, NASA's working on it.
Yeah, so that's important to remember, that there is this inherent sort of bias in how we collect our data, that we don't have the whole all the pieces of the puzzle. We're only able to collect data for certain exoplanets that behave certain ways. But from what we do know, I read recently that, in 95, when they first discovered the very first exoplanet, we didn't know before then for sure if planets formed around other stars. It kind of made sense, but we didn't know that. And now we know that it's actually common. It's common for planets to go to orbit other stars. Any star that you look up at in the nighttime sky, not all stars have planets, but on average, any random star you picked in the sky, it could have on average like 2.5 planets.
Right.
So they're super common, which is exciting. For me, it feels like an exciting time to live in. I mean, let's just be honest. It's exciting because we want to know what's out there. We want to know if we're alone or we're the only. It seems like a huge waste of space if we're just the only planet with life on it, right?
That's right.
And
not a good use of real estate.
We still have a lot to do in terms of even looking under all of the proverbial rocks in our solar system. There's still a lot to explore in our solar system in terms of looking for life. But exoplanets, that was my area of research, was studying what you call the habitable zone. So it's measuring the distance of planets in relation to its star. And there's a bunch of math, and you come up with, for my research, I studied the surface temperature. So it's the average surface temperature of a planet based on the kind of star that it orbited and how close it was to that star. And the reason you want to know the rough estimate of a surface temperature of a star is because of water. Because here on Earth, at least, everything here, or most everything here, needs liquid water to survive. And liquid water only exists at a very tiny temperature range, right? If it's too hot, the water boils. If it's too cold, the water freezes. Not suitable for life as we know it. So sometimes it's called the Goldilocks zone because it's not too hot, it's not too cold, it's just right. And so that's in this picture, that's what you're seeing, the green range there. You can see our solar system, Earth, is right in the middle of the habitable zone of the green range. It's the perfect distance from our star to have liquid water on it, which is why it's a water world. And then TRAPPIST has not one, not two, but 3 planets in its habitable zone. So my job as a lowly undergrad, it was really kind of a project. It was just to take Kepler's data, figure out that surface temperature of the confirmed planets, and figure out which subset of those planets, if water were present on their surface, which we wouldn't know, it would be liquid. And that's still, even if there was water and it was liquid, that still doesn't say that there was life on that planet, but it's one step closer. So I loved it. It was a lot of fun.
Yeah, no, I mean, that habitability, has been a goal. Figuring out what planets could possibly have life has been a goal of NASA for like 2 decades.
Yeah.
And we're so much closer than we used to be, because I mean, there used to be a joke that the Kepler people, like, I saw the Kepler people for years at science meetings, and they used to have this joke that we'll discover 50 Earth planets, but you should talk to us before you fly there so you can confirm your hotel reservations. And when all was said and done, they got pretty much close to 50 planets in the habitable zone. I mean, maybe a little bit less than that, but it's like in that right ballpark. And so, they were successful, so good on them. But now we have this huge bunch of objects that we can study in the future, right? That we can, okay, we know the planet's there, but now you might want to, okay, observe it with a different telescope or observe it again and get more information and, see if you can find signs of, things in their atmosphere or interesting stuff like that.
Yeah, and I don't know that we've really said this plainly, but discovering exoplanets is extremely difficult. They don't shine, they don't make light, they're dark, and they're orbiting something that is blaringly bright. So discovering exoplanets is difficult. They're also incredibly far away. Many light years, tens of light years, sometimes hundreds of light years away. So it's not like we can take a picture of them. Almost all of the planets we've discovered are indirect methods. So we don't actually see the planet, we just see evidence that it's there, like the transit method we've explained. So it's exciting, but there's still so much we don't know. There's still so much to learn, even about the planets that we've already confirmed that are out there.
Yeah. I mean, one of the things that interested me so much is when we first discovered a few, we're like, well, we don't really know patterns yet. And one of the things that all these surveys have found is that like our solar system is a little odd as far as we can tell compared to these other systems, is that the most common planet in the universe is slightly smaller than the size of Neptune. And so they get the clever name of mini Neptunes. And those don't exist in our particular solar system. We have Neptune, of course, but we don't have something that's, about half the size of Neptune. And then the next most common type of planet is what's called a super Earth, right? So it's bigger than Earth. It's about 2 to 3 times larger than Earth in size.
Mm-hmm.
And those don't exist in our solar system either. And I already told you about hot Jupiter. So to me, what's really fascinating is that's saying, okay, there's some interesting stuff about our solar system that is maybe not unique. I want to be careful, like, because it's unusual, right? That maybe our solar system isn't kind of as typical as we originally thought, bazillions of years ago when we were first thinking about planets. That there's these other weird objects.
I love that because you look around your surroundings and you just kind of assume like we have 4 rocky planets in close to the sun, and then we have 4 gaseous planets outside of those, and it's sort of orderly, and so it's like, well, maybe there's some sense out of this, but no, the universe is chaotic and doesn't make a lot of sense. And also, if you are a scientist of any kind, you know that a sample size of 1 is not a good way to make predictions. So if you want to predict what a solar system looks like, having only 1 to look at to compare it to is not it's not helpful, really. So now that we're starting to have more examples of solar systems out there, we're starting to realize that ours is not typical. But I'm wondering how much, and John, you might know this, how much of that is the selection bias. So the planets that we can discover, maybe because hot Jupiters are easy to discover, that we're finding those kinds of solar systems.
So that is always a worry for these kinds of things. Every astronomer, when we see something weird, the first thing we say is that we messed up the observation, and then the second thing is that there's a selection effect. Yeah. And I want to make it clear, it's just like for the transit method, I think it's pretty obvious that the bigger the planet is, the larger the transit would be. And so it's easier to see big planets than to see small planets, right? So now what's helped there's two things. Is one, there's a lot of smart people who know that and try to simulate, planetary systems with computers. But also, as Kepler and other missions have gone on, they've all found the same result, at least so far. Both Kepler, the mission after it called TESS, and other studies have shown that like it does seem that mini Neptunes are way more common now. But one thing you said that you pointed out is we only know about periods like shorter than about 1,000 days. So we still don't really have, we do know of planets outside of that radius, but they're much less common. And so I think I think even all planetary scientists would say this too, is that we know a lot now about the insides of planetary systems, the inner piece. The outside, maybe not so much. And that might be, that's something for the future, I think. Like, I think, to be fair, we don't, we have some ideas, but it might be that maybe the solar system is slightly less weird than I just made it sound. But it is kind of weird that the most common planets aren't in our solar system.
It's so orderly that it just kind of,
right,
with the human brain,
it was nice and symmetrical, right? There's four and let's not talk about Pluto. That's a different
there's
conversation.
some leftover material around.
There's some other stuff.
We're attached to it emotionally,
and we have a nice story, like, like there's a nice story that you and I both learned, like, okay, this is why there are these planets and there's why these planets, and now we're like, oh, maybe not. Okay, oops. So
we have a couple of great questions in the chat here. James asks, is there an age range of the stars that do have planets?
So of the ones that I'm aware of, most of them have been targeted at stars that are similar to the sun. So they're mostly older planets. For roughly the age of the Earth. Now, one very interesting result that happened a long time ago is that somebody went to try to look for planets in a globular cluster. And a globular cluster is a star cluster with very old stars, like 14 billion year old stars.
Like around the formation of our universe old.
Right.
Yeah.
And they did not find any planets there. And I think that result is still true. I don't think anyone's tried it again. They actually used the Hubble Space Telescope for a month to try that idea. So as far as I know, they're generally stars about the age of the sun or younger, in that ballpark. I don't think anyone has discovered planets around very old stars. They have discovered stars around a range of masses from, our star is what's called a G star. And then there's stars that are about half the mass of our sun. They've discovered planets around those, and they've discovered planets now around stars that are 5 times the mass of our sun. So those are actually very young stars, and that implies that you can make planets pretty fast. So
that's something that's come out in just the last few years. That was really excited to hear about that. Kind of our idea of how planets form around stars. I was sort of suggesting that it would take a long time, but new evidence suggests that that's not always the case, which means there's more to learn. So it's always exciting. I don't know if I know this for sure, but we haven't found exoplanets in star clusters, right? Not globular clusters with old stars, but star clusters with like younger stars.
I don't think so. I think most of them are what we would call sort of middle-aged stars. Super young stars, I do not think planets have been seen, though. People, of course, will look for them. I don't think anyone's found one yet.
Rajib asks, are we able to detect Earth-like planets at 1 AU from a G-type star? So we found an exoplanet that mimics very similar to Earth, where it's similar in size and similar in distance from its.
So there are a few Kepler sources that the answer is yes. Most of the Kepler sources are closer in than that have Earth planets, because again, right, like if a planet is teeny, it's harder to detect, and so that means your odds of finding it are less. They have found Earth mass planets at 1 AU around solar type stars.
And
They're
1
not.
AU is the distance between our sun and our planet Earth.
That's
So
right.
or basically, are we finding a carbon copy of that out there?
So the answer is yeah, but most of the Earth-sized planets are closer in than that. But I think
yeah,
that
and
is
a
a
lot of them
selection
are
effect.
bigger, right? Like 2 or 2.5 times the size of the Earth. Most of them,
Right.
yeah.
These are the super Earths, right?
Mm-hmm.
Where presumably Superman would live, but don't quote me on that.
So we want to talk about what we're doing now. I mean, I say we, neither of us are doing it, but what
The royal we. What astronomers are doing now. So Kepler was very successful, but it eventually ran out of fuel. Eventually, it actually had a very cool second life, and it ran out of its second life. But now there's a new satellite called TESS, TESS, that is doing something like Kepler. It uses the transit method, but instead of looking at one spot in the sky, it kind of circles around and looks at many bright stars. And the reason why this is so nice from an astronomy point of view is that means that the planets that they discover, the new planets they discover, are much easier to study with other telescopes. One of the things that was great about Kepler is it looked in one spot, but sort of a drawback of Kepler is that a lot of the stars were pretty faint, so it was hard to tell details about the systems. So TESS, I mean, I just read a paper this morning, has like 2,000 new planet candidates. Wow. Now, some of those won't be real planets. Like, they're very careful. When they say planet candidate, they're saying, well, some of these won't be planets, but a lot of them will be. So even
so
if
maybe they've seen the pattern twice and they're looking for it for a third time or something. Yeah.
Right. Yeah. So they are currently working on that, and they are definitely putting out discoveries, but it's one of these things where, like, there's something, and then a lot of stuff, because they start confirming lots of these objects. Mm-hmm. So, and then of course, we are obligated to say, when the James Webb Space Telescope is launched, quick, everyone knock on something.
It's right? Looking like it's going to be this October, I think.
Yeah, knock on wood, everyone, please. Like, So this is the successor to the Hubble Space Telescope. It's a much larger telescope. It's an infrared telescope, and so it will really revolutionize exoplanet research, because all these objects that these other telescopes are finding, James Webb can then do some amazing things, like look at the atmospheres of these extrasolar planets. They can, do fancier studies, more detailed studies of different aspects of these systems. And so then it's not just finding the system, it's like, what are the details of the system?
Nice. I'm excited. It's going to be one of the most sensitive space telescopes that we've had. So regardless of what kind of science it does, which I do know it's going to do some exoplanet research, we're going to have better data than we've ever had before. So it was supposed to launch in October of 2018, but stuff happened. And now it's set for Halloween this year, but we'll see if it gets postponed again. It's almost become a little bit of a joke in the community that it keeps getting postponed, but that's because they have to get it right. With Hubble, they could go, astronauts could actually go and did go and service that telescope and fix it and make repairs. James Webb Space Telescope is going to be orbiting Earth so far away, even further, way further than our moon. So we won't be able to just get in a spaceship and go fix it if something breaks. So, all respect to them, that's a tough job, but we're all excited.
Oh yeah, I'm excited, but I always have to sort of act like, oh, it'll be okay if it, we're all sort of, I mean, the entire astronomy community is like, yeah, there'll be a lot of cross fingers, take out the lucky rabbit's feet.
But so in terms of the future of exoplanets, you mentioned this earlier, that our instruments are starting to get sensitive enough that we could measure. So we're really good at being able to measure the chemical composition of, or the elements in a star, but studying its light. We can get a lot of information just by studying a star's light. Well, we can get information about an exoplanet's atmosphere by studying its starlight shining through the atmosphere. You can take out the information from the star and just see what's left, and then suddenly you have the components or the elements that are present in that exoplanet's atmosphere. And this is exciting if you're like me and you want to answer that big question of, are we alone? Because we know of what we call biosignatures, things that could not be present in an atmosphere of a planet without intervention. Something would have to create that.
Yeah, I mean, so this has been done, everybody, by a smaller infrared telescope that was called Spitzer. And they did it for a couple planetary systems, and they know that certain planets have certain elements in their atmospheres. But what Tiffany's talking about is the big enchilada is that certain, I mean, this is where like both she and I, not being biologists, kind of smile and nod, and biologists tell us that, well, certain features from plant life or animal life show up in the atmospheres of planets if they're, like the Earth in terms of their biology. And those features aren't created by like volcanic or geological processes. So if we see those features in one of these spectra, we get very, very excited, because that does mean there's some form of life on this planet. Now, that's as super tricky, as Tiffany said. What you have to basically do is take a spectra of the star, and then as the planet it goes behind the star, well, okay, it's just the star, and then the planet moves in front of the star, you get a spectra, and you have to subtract the two super carefully. But if you can do that, and of course you can do this as many times as you need to until you're sure, but those features there's no other way to make those features that we know of. And so that would be incredibly exciting, because that would say that life is, I mean, as Carl Sagan said years ago, right, that life would be an abundant thing in our local universe. And that would be an amazing discovery right there. Now, we're not even talking about like intelligent life. We're talking about, well, this planet could be planet algae. And the reason I say that is not to be snarky, but like that's actually how the Earth was for almost several billion years, is that there was life on the Earth. It was algae. Like us and animals did not exist for a long period of time in Earth's history. It was this like algae planet. So we could have that kind of situation, but even just that would be an amazing discovery.
Yeah, fundamental shift in how we view ourselves in the universe. Akin to like when we discovered that the Earth wasn't the center of the universe, the Earth orbited the sun. That was a huge shift in humans' understanding of their place, and so this would be really cool. It has not happened yet, but exoplanet research is where you're gonna see that if it does happen, I think, or planetary research. I mean, you can't rule out the possibility of life, not intelligent life necessarily, but life here in our solar system. There's some good candidates. Europa is, we know it has liquid water underneath a shell of ice. So maybe there's, microbial life there or something. Who knows? But it's fun to think about.
It's definitely fun to think about. I mean, and yeah, I there are people talked about Mars as well, Enceladus, the moon of Saturn that has these amazing cryovolcanoes, which means there was liquid water underneath somewhere. But yeah, I mean, those kinds of things are very exciting. I mean, it's not my field because chemistry and biology scare me, but I freely like exoplanets is like, and this kind of what's called exobiology, this idea of looking for even primitive life, is an amazing scientific field. And I know there's going to be something cool. I don't know what that discovery will be, but it's going to be something amazing.
Yeah, so if all this sounds really cool to you, you can go to school to become an exobiologist.
Absolutely.
So
That there are astronomy schools and planetary science schools that do that stuff, and I would encourage you to look into them.
well, I'm not seeing any more questions. John, was there anything else that you wanted to add to this? I could talk about it forever, but
Yeah, I mean, I guess I'll just repeat something we both said, is that this is a very exciting field, and frankly, this is why I got into astronomy, is that in certain science fields, like, they know most of the big picture, like chemistry. Sorry, they do know most of the big picture of chemistry. But like, if you'd told me, when I was a undergraduate student, that, oh yeah, there's going to be like these, mini Neptunes and mega Earths and hot Jupiters, I'd be like, you're crazy. That's not right. I mean, there are exciting discoveries in this field pretty much every week. Like,
yeah,
of when I teach astronomy, this is actually the section of my notes that changes not just a little bit, but drastically. And that's what makes it so interesting, is that we learn more and more, and yet there's still a lot of surprises. And that's, I think, why I got into science, and I think a lot of other people did. And so this is a genuinely, like, what's going to come up next, I don't know, but it will be something amazing.
yeah.
So that's my last thought.
All
What do you
right.
got, Tiffany? You say anything profound on your own?
Oh, well, nothing that's going to sound that great.
I doubt that.
No, I think this is an area that sort of showcases why astronomy is an inspiration to and is related to so many other areas, art, even other sciences, of course, but art and history and psychology and I think exoplanets is a great example of this, because it's an interesting science, just in the sense that we're discovering so many new things and what's going to happen next. But it's also that sort of idea of answering the big question and looking for life. So yeah, it's one of my favorite areas of astronomy. Well, I want to thank you, John, for coming out and talking with us. And I know it was finals week at YSU this week, which is tough on the students, but it's also tough on the professors. So thank you for ending your week, or starting this first week with us after a tough last week. Not seeing any more questions, but if you guys have questions for us, if you're watching the show after, when we're no longer live, we'll still be checking the comments. So please feel free to ask any questions, and we'll follow up with you in the comments below. Thank you for joining us. This Saturday, we'll be talking on our Keep Looking Up show, Saturday at 8 o'clock. What are we talking about? Oh, star lore. Oh, it's going to be so fun.
Nice.
Yeah. So we're just going to tell stories about the stars for 45 minutes or so. It'll be great. All right. I think that's it. Thank you, guys. See you later.
Bye, everybody.